Hello again, everyone. This is the practice problem video for Chapter 11. Got a short set here for Chapter 11 to cover. First up is Exercise 11-1. So that said, Alaska Services Company, a division of a major oil company, provides various services to the operators of the oil field out there in Alaska. Here's data concerning the most recent year: sales of $7.5 million, net income of $600,000, and average operating assets of $5 million. So the first thing we're going to calculate is margin, then turnover, and then we'll calculate return on investment, or ROI. And do that two ways, actually, just to make sure we're clear on these interrelationships. So this margin is overall profit margin, essentially. I know we have several different margin measures in this class. This one, net income then of $600,000, divided by sales of $7,500,000. Right? What portion of sales dollar makes it through to that very bottom line net income? In this case, that's 0.08, or sometimes expressed as 8%, right? 8 cents on the dollar. Turnover is that measure of productivity, the usage of our assets. So we take our sales there of $7,500,000 and divide that by our average operating assets of $5 million, and we get turnover of 1.5. Kind of say that we would turn over our assets 1.5 times in generating sales every period. Okay, so ROI then we can calculate as margin times turnover, so 8% times 1.5, or 12%, or 0.12. We can also calculate that sort of directly, if we had all this same information, by taking our net operating income of $600,000 divided by those average operating assets of $5 million. You get the same 12% measure. So just wanted to make sure we kind of re-highlighted the interrelationships between those things. All right, moving right along then to 11-2, right below that. Let's do a quick calculation here of residual income, another performance measure that is fairly common in practice and was designed to overcome some of the limitations of ROI in some cases. So that said, Juniper Design provides design services to residential developers. Last year, the company had net operating income of $600,000 on sales of $3 million. The company's average operating assets for the year were $2,800,000. and its minimum required rate of return was 18%. So we're going to calculate residual income for this scenario and then talk a little bit about that measure as well. So remember, residual income is the income generated above and beyond that capital charge, that minimum required rate of return. So if we take our net income of $600,000 and subtract off that capital charge, in this case, we're saying that's required rate of return of 18% times those average operating assets there of $2,800,000. So actual net income $600,000 minus the required return on those assets of $2.8 million, 18% of that, gives us residual income of $96,000. Now, I will point out quick here that we often know a little bit about the relationship between ROI and residual income based on how either of those numbers comes out. And by that I mean residual income of $96,000 means the company's actual return, the return on their investment, has to be something greater than the required rate of return of 18%, right? Since that's that minimum required rate of return used to calculate residual income in the first place. If the actual return had been less than 18%, residual income would be negative. If the return had been exactly 18%, residual income would be exactly 0. Right? So we want to keep those relationships in mind just in terms of a logic check, and also understand the relationships between these different income and return components. Okay, I'm going to jump ahead just a little bit here to 11-6. Gives us a chance to sort of compare and contrast the two measures directly. So 11.6 said Tan Corporation of Japan has two regional divisions with headquarters in Osaka and Yokohama. Here's some data for the two divisions. So we've got sales, net operating income, and average operating assets for the two. Now for each division, we want to calculate margin, turnover, and ROI. And where necessary, carry that out to 2 decimal places. Then we'll worry about that second piece. So this is Osaka, and I'll put Yokohama right next to it here. First up, we've got the margin measure. Again, this is overall profit margin. So for Osaka, that's net income of 210,000 divided by the sales of 3 million. So their margin, 0.07 or 7%. Yokohama had net income of 720,000 versus sales of $9 million. So their margin, 720 divided by the 9 million, is 0.08 or 8%. Next up, we've got turnover. Osaka had sales of 3 million divided by average operating assets of 1 million. So they turn over their assets 3 times per period on average. Yokohama had sales of 9 million divided by those average operating assets of 4 million, and their turnover was 2.25. So now let's calculate ROI, and we'll do it both ways just to be complete here. So Osaka had that margin of 7% times turnover of 3 for an ROI of 21%. Yokohama had margin of 8% times that turnover of 2.25 for an ROI of 18%. Let's calculate that directly. For Osaka, that would be their net income of 210,000 divided by the average operating assets of exactly $1 million. So same 21% there. Yokohama, net income of 720,000 divided by the average operating assets, 4 million, and there's their same 18%. Now the second piece said, assume the company evaluates performance using residual income, and the minimum required rate of return for any division is 15%. Compute the residual income for each division. So one thing to point out real quick here, required rate of return is 15%. ROI for Osaka was 21, Yokohama 18. Both these numbers then should be something greater than 0. Both these divisions had return greater than that minimum required rate of return. So let's see what it was for Osaka here. They had net income again of 210,000. We'll subtract from that the required return on their assets. 15% of their assets of $1 million. And there's residual income of 60,000. Yokohama had net income of 720,000. We'll subtract the capital charge there. Required return of 15% on their assets of $4 million. And they had residual income of 120,000. Now this problem didn't ask us specifically, but really it's leading us to sort of think about these questions of comparability. If we have 2 divisions or 2 parts of the company side by side, we're trying to decide who's doing better maybe. It's tempting to look at either performance measure and try to make that judgment, but this is where there's a pretty important difference between the two. If we looked just at residual income, we would say, wow, Yokohama generated twice as much residual income. They must be really killing it. Must be doing so much better than Osaka. But residual income is inherently biased by the size of the division. And so look at the size difference here in assets and sales. Yokohama 4 times as big in terms of assets. So they should be generating, all else equal, more residual income. Right? Again, it's kind of inflated or biased by differences in size. If we look at the actual return on investments though, Osaka's generating 21% return on their assets, Yokohama 18%. So ROI, since it's scaled by assets as part of the measure, really provides a more comparable view of that performance, side by side. if we're trying to answer this question of who's doing better, ROI is probably our best bet. Right? It tells us the actual return being generated on the division's assets. Okay, so it accounts for those differences in size inherently. Just something to keep in mind there. Right, I'm going to jump ahead a little bit again to 1113. I'm going to look at some transfer pricing considerations. So 1113 said, in each of the cases below here, A and B, assume that Division X has a product that can be sold either to outside customers or to Division Y of the same company for use in its production process. The managers of the divisions are evaluated based on their divisional profits. So we see capacity, number of units being sold to outside customers, from Division X here. We also know the selling price, variable cost per unit, and fixed cost per unit based on capacity. Now Division Y needs 40,000 units for production. So they're either going to get it from Division X internally, they're going to get it from an outside supplier at the cost shown here at the bottom. So the first piece said refer to case A only, so the left column here. Assume in this case that $3 per unit in variable selling costs can be avoided on intra-company sales. So this number reduced by $3 if we sell internally. Part A, so this is 1A, said what's the lowest acceptable transfer price from the perspective of the selling division? That's Division X. Thinking back to what you read in Chapter 11 was covered in notes, the lowest acceptable transfer price from the seller is always going to be the variable cost per unit plus the opportunity cost, if you will, of selling to the internal customer rather than the external customer. So that's the opportunity cost of any lost sales to outside customers by doing this transfer internally. So let's see what that is for this first scenario. The variable cost per unit of this product is $70, but it also told us that could be reduced by $3 by avoiding some selling costs if we do this internally. Okay, so the true variable cost in that scenario A is $67, variable cost per unit. Now to that, we want to add that potential opportunity cost of lost sales to the outside customer. And we express that really on this per unit basis. So Division Y is going to want to buy 40,000 units from Division X. Division X right now in case A has no excess capacity. So to sell these things to Division Y, they're going to have to give up 40,000 units of sales to outside customers. Okay. So what this is then is the price to the outside customer, $90, minus the variable cost per unit of $70. So we're saying a contribution margin of $20 per unit, right, times the 40,000 units given up, and then dividing that whole thing by 40,000 again. Okay, we're spreading it out over the number of units that Division Y is going to purchase from Division X. So in this case, that comes out to $20 that's per unit. And I'll just mark this as op cost of lost external sales. So the minimum acceptable transfer price then is the sum of those two, $67 plus $20, or $87. Min acceptable price. Okay. Now B said what's the highest acceptable transfer price from the perspective of the buying division. Now for the buying division, it really hinges on what else they can buy that product for in the external market. Here it said purchase price per unit now being paid to the outside supplier, $86. So we're not going to pay any more than that just to get it internally, right? It wouldn't make any sense. So that highest acceptable transfer price, $86. So now C said what's the range of acceptable prices, if any, between the two divisions? If the managers are free to negotiate, will a transfer take place? Well, Division X has a minimum acceptable transfer price of $87. Otherwise, it's better for them to sell to the outside customer all their units. Division Y has a maximum price of $86. So there's no overlap between the two, right? 86 doesn't meet 87. So no acceptable range of transfer prices, and no transfer will take place. Again, point being, we're going to make the company worse off as a whole if we make this transfer internally. It's better if X just keeps selling to the outside customer and Y goes out to the market there and buys everything for $86, okay, given the parameters shown here. Okay, number 2 said refer to case B, so that's the right-hand column there. In this case, there'll be no savings in variable costs on intra-company sales. Everything just is as it's shown here. What's the lowest acceptable transfer price from the perspective of the selling division? Okay, well, variable costs per unit in this case are $60, and we don't have any change to that for any avoidable selling costs or anything like that. So here's $60 BC per unit. Let's see what this opportunity cost is. Right now, Division X has 40,000 units of capacity. Division Y needs 40,000 units, so they wouldn't have to give up any external sales. So that cost becomes 0. So now the minimum acceptable transfer price for Division X, just to be explicit here, 60 plus 0, or $60. The second part said, what's the highest acceptable transfer price from the perspective of the buying division? So again, we're going to key on this purchase price being paid to the outside supplier. Right now, they're doling out $74 a unit to get these things. So certainly not going to go higher than that to buy it internally. So now we have a different situation. Now C said, what's the range of acceptable transfer prices? And again, is the transfer going to take place or likely to do so? Now we've got a minimum price from X of 60, a maximum price from Y of 74. So the range is that 60 to 74. Anything above 60, makes it better off for Division X to supply these things to Division Y. And anything less than 74 makes it better for Division Y to buy these things internally. Anything in between those makes the company better off as a whole. So yeah, a transfer will likely take place. And again, point to make, it makes the company better off as a whole. And we certainly want to make sure for this company, we're encouraging that behavior. We're letting them negotiate maybe, or we're doing some other kind of transfer price mechanism, but we want to make this happen. Makes everyone, all the better. Okay, I had one more problem I wanted to cover here related to charging of support costs, and that's back up a little ways here, 11-4. Okay, so that said Hannibal Steel Company has a transport services department that provides trucks to haul ore from the mine to the two steel mills, the northern plant and the southern plant. Budgeted costs for transport services were $350,000 per year, consisting of 25 cents per ton in variable costs and $300,000 in fixed. The level of fixed costs is determined by peak period requirements. During that peak period, northern plant requires 70% of their capacity, and the southern plant requires 30%. During the year, the Transport Services Department actually hauled 130,000 tons of ore to the northern plant and 50,000 to the southern plant. The Transport Services Department incurred $364,000 during the year, of which $54,000 was variable cost, $310,000 was fixed. So first up said how much of the Transport Services Department's variable cost should be charged to each plant. So let's lay this out here for the northern plant and the southern plant. Okay, so this is variable costs. Now, in Chapter 11, you read that these service department charges for variable pieces should be based on the actual activity and that estimated sort of rate, if you will, for the variable support or service cost. So for the northern plant, that means the 130,000 actual tons that were hauled by Transport Services to the northern plant times the 25 cents per ton, 32,500 charged to the northern plant for the variable cost there. Same idea for the southern. They had 50,000 tons actually hauled to them right here, times the 25 cent per ton rate, variable rate. And there's charges of 12,500. Now the fixed costs should be charged based on the peak period requirements, right? So here we were told that was 70% for northern, 30% much smaller for the southern. So the fixed cost being charged here for transport services would be 70% times that expected fixed cost of $300,000. The expected fixed cost. Similar idea for the southern. We've got 30% of the fixed cost. Again, that's the expected fixed cost of $300,000 for a total of $90,000. So let's kind of foot our totals here across and down. Total variable costs charged then, $45,000. Total fixed costs we're saying are the $300,000, so we've accounted for everything here. And then let's get totals for the two plants. Northern we're saying would be charged $242,500. Southern would be charged $102,500. All right. Part 2 said how much of the Transport Services Department's fixed cost should be charged, so we've already covered that. And then 3, should any of the Transport Service Department's actual total cost of $364 be treated as a spending variance and not charged to the plants? So let's think about this. Let's reconcile the variable and fixed costs of the Transport Services Department to what was actually billed, right, or charged. So actual variable for the year it's set down here was $54,000. Actual fixed was $310,000. So the grand total, the sum of those are $364,000. And then charged out, well, we knew that in total the variable costs charged to Northern and Southern were $45,000. Total fixed charged out $300,000 for a total of the $345,000. So let's see what we've got for the difference. For variable cost, that's $54,000 minus $45,000, or $9,000. For fixed, that's the $310,000 minus the charged out and expected of $300,000, or $10,000. Point being, getting back to the original question, should be treated as a spending variance and not charged out? Yes, absolutely. Right? These are overages, quote unquote, or however we want to think of them, these variances, spending variances, incurred by the Transport Services Department. That's not the problem, if you will, of the northern and southern plants. It would be very dangerous for companies to bill all charges out like this to the individual segments or divisions or plants, because it wouldn't give anyone any incentive to control costs in the Transport Services Department, right? If you knew everything was going to be covered by the internal customer, no matter what the costs run up to, there would be no incentive to control costs or to be efficient in any way. Okay, so these differences, we're going to say yes, treat as the spending variance and not charged off to the plants. Okay, it's just going to affect the bottom line of that Transport Services Department. Okay, that is the end of the Chapter 11 practice problems. If you have any questions, please do let me know. See you next time.